Greetings of the day, dear students. In this video, we are going to discuss about the Zener diode as voltage regulator, right? How it acts like a voltage regulator and its circuit diagram and its waveform, some equations, right? What are the equations we are having and what are the different cases we are having with respect to the Zener diode as voltage regulator in this video. This is one of the application of a Zener diode, right? Now, dear students, please observe, if you want to control the voltage across the load, it can be achieved with the help of this Zener diode, which is connected in parallel to the load. Now, the breakdown voltage of this Zener diode can range from 1.2 volts to 200 volts. How do we understand that? For example, if you have connected a Zener diode which is having some breakdown voltage of 12 volts, up to 12 volts, right? The moment it crosses the 12 volts, there will be high conduction in the diode and it acts like a short circuited path, right? And the entire current flows through the diode the moment it crosses the 12 volts, if it is some 12 volts example, right? So because of that, what happens? This load gets operated only for the voltages less than 12 volts. The moment the input voltage has crossed 12 volts, because of the breakdown voltage of the Zener diode, what happens is the entire current flows through the diode. No current flows to the load. Depending upon the breakdown voltage of the diode we have selected for particular application. Right? Now, as these two are connected in parallel, as long as the voltage is less than 12 volts, for example here if it is the Zener breakdown voltage, that voltage will be available across the load. Both are connected in parallel. Now, for example, it also provides the path for the excess current. If any excess current is flowing, right, because of the input applied voltage, it will not allow to flow to the load. That will entire excess current will flow through the Zener diode. If you observe, it's KCL at that node point, whatever input current is coming or entering, that is equals to the current flowing through the diode plus current flowing to the load. Now our output voltage is nothing but the voltage across the Zener diode, because both are in parallel, right? Now what about the input voltage? The voltage that is dropped across the resistor. Observe here, whatever voltage we are applying as an input voltage, this input voltage will be equal to the voltage dropped across this path. Nothing but IR amount of voltage is dropped, and now some VZ amount of voltage will be available across the diode. Now sum of these two will be our total input voltage, right? So here, if you observe, our input voltage will be equals to the IR drop across the resistor plus voltage available at the output. Nothing but here in this context both are in parallel. The load and Zener diode both are in parallel. Nothing but the diode voltage across the diode VZ. So obviously what will be the output voltage then? Input voltage minus drop will be the voltage available across the load. Now based on that, what should be the value of resistor can be decided. How much value of resistor to be connected in this circuit will be decided based upon the value of output voltage required and what is the value of input voltage and also current flowing through the diodes. Based on all those things, the value of resistance is to be selected. So R is given by V input voltage minus V out divided by ID plus IL. ID is the current flowing through the diode, IL is the current flowing through the load. Now we can observe two cases here. For example, in case 1, R is already kept constant, R is kept fixed, but there is a slight increase in the input voltage. Because of that, what will happen? the current I also will increase. The input current also will increase. Because of that, what happens? This IL, but the current flowing to the load will be constant. Even though I has increased, ID value will get adjusted in such a way that ID current flowing through the diode will get adjusted in such a way that IL will be remained constant. IL will remain constant even though the input voltage is increased, right? And V input is increased. Due to that, I also has increased, but IZ current through the diode will adjust in such a way that overall IL will be kept constant. Overall IL will be kept constant, right? So because of that, what happens? Once IL is kept constant, right? If any changes in input voltage, I and IR will change in such a way. The current I and IR will change in such a way that overall voltage across Zener diode also will be kept constant. VZ also will be kept constant. But current through the diode will change. Current through the diode will change. But voltage across the diode will be kept constant. That is important. Don't get confused. Clear? Right. Similarly, if input voltage is fixed, another case is also possible. Input voltage is kept constant, but there is a change in the current drawn by the load. At that time also, again, current through diode will get adjusted in such a way that overall VZ remains constant. Overall VZ remains constant. So what we can conclude is either if V input or IL changes, current through the load changes, okay, ID current through diode adjusts in such a way to keep voltage across the diode VZ constant. Very important, to keep the voltage across the diode constant. Clear? Right. So this is what all about the Zener diode as a voltage regulator. And this entire discussion, the important point is what should be the value of external resistance to be added. Simply based upon this formula, V input voltage, whatever input voltage we are applying, that will be wasted or dropped. Some value is dropped across resistor IR. Remaining part will be available across the output. Now our output will be nothing but simply input voltage minus drop. Now if you want R, input voltage minus output voltage by total current I. But if you observe, if you apply KCL at that point, I is nothing but ID plus IL. ID plus IL. Very simple. So this point is to be highlighted. The value of external resistors are to be connected, right? So this is about the Zener diode as a voltage regulator. One more important point is this diode, Zener diode, will be kept in parallel to the load RL, right? Okay, thank you.